Hello everyone. The title of the paper is Machine Learning Model for Congestive Heart Failure Prediction presented by Hinduja. Heart attack is one of the serious health issues faced by many of the people irrespective of age. It should be seriously considered and the patient should be saved from the danger of mortality due to the heart attacks. There are several diagnostic measures taken by the medical experts nowadays, but they are all very costly and takes much time. uh, there will be much time will be taken in diagnostics rather than the treatment. So the major aim of the paper is to develop a machine learning model which can be deployed in the real time that can predict the heart failure in prior in the patient so that the patient can be given treatment and can be saved from the probability of the occurrence of heart failure. This is the overall methodology followed to create machine learning models and the deployment. Um, and the data set for the major aim of the major thing we have to do before the creating the machine learning models is the collection of the data set. The data set has been collected from the open source repository, which is the Kaggle. It contains 919 patient records with several features like age, chest pain type, blood pressure, cholesterol level, and several ECG factors and all. Then we have to pre-process the data in order to deal with the missing values. Several imputation techniques have been followed for this data pre-processings, and in addition to the handling the missing values, we have to handle the categorical values so that we can convert into numerical values in order to make the training of the model easier. After pre-processing the data set will be ready for the machine learning model creation. Before we directly jump into the creation of the machine learning models, we have to analyze the data. So we perform some exploratory data analysis methods, which is nothing but the plotting of the data, plotting of the different attributes with the output attribute, which is the heart disease, that is the positive or negative value, whether the patient will likely to have the heart failure or not. So these graphs signifies that how each and every feature is affecting the output of the model. These are some classification algorithms. I have chosen 5 classification algorithms, which are mainly support vector mission, logistic regression, k nearest neighbor, decision tree, Catboost classifier for the development of the models. Um, Here, we can notice that support vector machine, decision tree, logistic regression, and k nearest neighbors are standard machine learning models, which we normally create. But Catboost classifier is something different from the rest of the models. In how is we can explain that the Catboost classifier as gradient boosting algorithm, which means it creates multiple machine learning models and the best model will chosen from the previous one. Um, Specifically, Catboost classifier will create multiple decision trees, and each decision tree created will be better from the previous one, so that the model we are getting finally will be of the best accuracy and the best performance. So these are the some of the accuracies which we obtain from each and every model. We can see that the Catboost classifier has reached the highest accuracy of 88.59% of accuracy. In addition to the accuracy, for a model to be evaluated, only the accuracy parameter is not enough. We have to consider other parameters like AUC, recall, precision, F1, kappa, MCC, and etc. to evaluate a model's performance. So these are the multiple confusion matrix for each and every model. The above parameters are considered for the prediction of the correct output from the model. What if we want to handle the wrong outputs as well? For this purpose, the confusion matrix values are considered for choosing the best model. The false positive case is considered for choosing the best model. The false positive value indicates the model predicting the result to be positive so that the patient get diagnosed, however, thereby reducing the danger of ignoring a person from getting from being getting diagnosed. In short, we can say that more accuracy and good false positive value, the better the model. We can say that the Catboost classifier has relatively higher false positive values other than the rest of the models. So after the model creation and we have chosen the best model, which is the Catboost classifier, we have to deploy this model into a actual user interface so that it can be used by the society, that is the doctors, for the diagnosing the heart failure in a patient. For that one, a mobile application has been developed which will be compatible for both Android and iOS applications. It is a simple user interface which gets several medical features and common ECG factors from the patient, from the doctor, and using these features, the output will be generated, which is the patient is likely to have a heart failure or not. If the output is positive, then he or she will be, the patient will be further diagnosed and treated with the further be processed for the treatment purpose. For this model creation, um, an API has been developed from the machine learning model using the Pickle library and the Flask library. This API has then been implemented in this user interface so that the inputs which we are entering in the user interface then be passed to the API in the form of dictionary values, in the form of JSON format, and we get the output from the user interface in the form of the JSON format, which is the final output from the model. So the conclusion is the ultimate aim of the model development is to make the product readily available for any kind of circumstances. Um, so this has been ultimately achieved by the developing a mobile application. Beside this user interface, you can see this user interface doesn't need any complex medical features. It only needs certain basic medical history of a patient and some of the ECG slopes, which will be uh, which will be enough for the user interface. Thank you.